Let's look at 12. What is the zero momentum reference frame for a system? Okay. And how can you use it to solve a problem if the only velocity data you have for the system were measured in a different inertial reference frame? Okay. So what is the zero momentum reference frame? Well, let's go here. Well, just in a simple example, so now you've got two objects. It doesn't really matter, they may be traveling like this. It's object 1, object 2, object 1 has a velocity 1 and a velocity 2. And you're standing over here and you're observing this, okay? And basically you can be considered to be in the Earth reference frame. So the velocity 1e, velocity 2e in the Earth reference frame. Okay, we've got those. So number one, what is the zero momentum reference frame? Well, believe it or not, it is a reference frame where the momentum is zero. Okay, so what do we mean by that? The way I like to understand it is, in any system we have something called your center of mass. Okay, so if I consider that to be my system, then even if these two objects are moving at different velocities, and even if they collide and move away from each other, right, they go through a whole collision process, as long as this is an isolated system, okay, as long as that's an isolated system, then my center of mass will be moving at a constant velocity center of mass. Okay, go and watch the videos, go read the various sections. Okay, so now the velocity, so the zero momentum reference frame, okay, is a reference frame that is moving at the velocity of the center of mass. I'm going to repeat that. The zero momentum reference frame is a reference frame that is moving with the center of mass. It is a reference frame that moves at the velocity of the center of mass. So that if I calculate in this reference frame, right, a reference frame that's moving with the center of mass, if I then calculate the momentum of these two objects in this reference frame and I add them together, I will get zero. I will get zero momentum. Okay? In this reference frame, the momentum in this reference frame is not necessarily zero, but if I'm moving in this reference frame with the center of mass, then if I calculate mv plus m, so m1 v1 plus m2 v2 in this reference frame, then they will equal zero. Okay, so how do I actually calculate it? Well, we know that the zero momentum reference frame is calculated by taking, well, just remember, P equals mv, right? So P of my system is the mass of the system times the velocity of the center of mass. And this velocity of the center of mass is the same as the velocity of the zero momentum reference frame. Okay? I forget the exact notation now, but it's the zero momentum reference frame. Okay, these two are the same thing. Okay, so if I want to calculate the velocity of the zero momentum reference frame, I need to say P of my system divided by the inertia of the system. So it's going to be m, and by the way, this is in this reference frame, right? So m1 v1 in the Earth reference frame plus m2 v2 in the Earth reference frame. So I'm now looking from the Earth reference frame and I'm trying to calculate this center of mass velocity, or the velocity of the zero momentum reference frame. So then I divide that by the total inertia, m1 plus m2, and I get this. This is my v center of mass, or my v zero momentum reference frame. Okay, So it's going to give you a certain speed, okay, a velocity. And so this is the velocity now of this zero momentum reference frame. So now I can go and recalculate the velocities of these two objects in this reference frame by simply subtracting this value from this speed, from this velocity, and this value from that velocity. Right? So this velocity in the zero momentum reference frame is this velocity minus that, and this velocity in the zero momentum reference frame is this velocity minus that velocity. And then if I calculate my new velocity in the zero momentum, my new momentum, P0 momentum reference frame, it's M1 V1Z plus M2 V2Z. Okay? Then this equals 0. Okay? Hope that helps.